Hi, everyone. Can you hear me? Cool. Ace. My name is Boris, and today I want to talk about lessons from self-hosting ClickHouse. The ClickHouse team talked about the managed service. That is awesome. And I made the decision a long time ago to self-host it. And that is me. Um, it's been a journey over the past 2 years and a half self-hosting ClickHouse. So why am I even self-hosting ClickHouse in the first place? I was the founder of a company called Baseline. We were doing observability for the next frontier of cloud computing, like the edge, serverless, all of that good stuff. We were helping developers with their logs, metrics, and traces for that. And about 2 months ago, we got acquired by Cloudflare. However, this talk is about our experience at Baseline, not the Cloudflare one. At Cloudflare, there is a massive team that is managing what, 4, 5, 6,000 ClickHouse nodes. So this talk is not about that. It's about, a startup of what, 3 engineers managing ClickHouse themselves. Yep, so that's what I was saying, application observability for the next frontier of cloud computing. That's what we were doing. And the question is, what is observability? I think a lot of people think that observability is collecting logs, metrics, and traces, putting them in S3, and every now and then running a query on them. That is not what we believe observability is. Observability is actually about understanding your system from what it spits out. So your system might spit out logs. That is a good start, but it can also spit out wide events. It can also spit out traces. It can also spit out just metrics or whatever thing that your system emits. You should be able to understand your system based on those things and ultimately solve all the problems that you have. Like you want to wake up at 2 a.m. because there is a bug and be able to fix it before 2:30 and go back to sleep. So how much data were we ingesting or are we ingesting? About 15,000 events per second. And we were just a team of 3 engineers up until very recently. It was a lot of fun managing this. How does it work? So we use OpenTelemetry to instrument Lambda functions, Cloudflare workers, Vercel, whatever they call it, fly.io servers, all of that kind of stuff. OpenTelemetry to instrument, and then all the data is sent to Cloudflare workers for data processing, all of that transformation, filtering, all of that good stuff, and then sent to ClickHouse for storage and indexing. And on the other side, you had your API, your browser, your CLI, etc., to actually query that data and do something interesting with it. Why did we pick ClickHouse? Because it's schemaless. I mean, it's not schemaless by default, but you can make it schemaless. The main thing with logs and traces is that a developer is not going to tell you beforehand, hey, my logs are going to look like this, process them accordingly. They are going to send whatever they want, and it's up to you as a provider to actually process it and enable them to query it in an efficient way. The other interesting thing or good thing about ClickHouse is that you can actually store high cardinality and dimensionality data. High cardinality data is something that can take a billion values, a request ID, right? A request ID can take a billion individual values over a single day. You need to be able to query it, to store that, index it, and query it in an efficient way. And high dimensionality data, what is high dimensionality? I forgot. I say this all the time. Yes, wide events. So you need to be able to send one event that has 100 columns. So when you send a span or a span of a trace, you shouldn't be limited to only 15 fields. You should be able to put 100 fields in there. All of that need to be indexed, and you need to be able to query across any of those 100 fields. And obviously, ClickHouse is super fast. Why did we self-host? Because we thought it would be fun to self-host it ourselves. And when I say ourselves, it was really me that made that decision. It was really dumb. And also, ClickHouse Cloud at the time wasn't around or it was in closed beta or something like that. It was about 3 years ago now. So we didn't have access to all the expertise that the guys are putting together now. And also the unit economics of observability. Observability is actually a pretty interesting market because, yes, Datadog makes a crap ton of money, but there isn't actually a lot of money in observability because everybody's trying to cut cost. And as a provider, if you're spending way too much on your data storage, well, you will not be able to compete against, everybody out there. So those are the main 3 reasons why we decided to self-host ClickHouse. What was our architecture? Again, not 1,000 nodes, just 4. 4 nodes on bare metal EC2 instances, with SSDs. We were not using block storage for performance reasons. So 2 shards and 2 replicas per shard. That's how we were doing it. And we were using ClickHouse Keeper to essentially coordinate all of these nodes together. How is it going? That is the thing. Coming up into a room and everything is on fire almost all the time. So today I want to share with you 10 lessons from operating ClickHouse. So these lessons, some of them might sound obvious, but these are things that we failed at. And these lessons are not for operating 4,000 nodes. They are for operating a small cluster with a small team. And also, it's not about how to set up your ClickHouse tables or your ClickHouse cluster, etc. It's more about how to stay sane with ingesting 15,000 events a second. So, first thing is, sending data in small batches to ClickHouse is a very bad idea. Don't do it. It says in the docs, don't do it. If you do it, it's gonna work until it's gonna stop working. And when it stops working, you're gonna have a very bad time. Why is that? It's because of too many parts. Anybody who has tried to send small batches to ClickHouse, it's really easy to send small batches to ClickHouse, especially for real-time analytics. You get data in real time, you batch it, 1 megabyte at a time, and then you push it to ClickHouse. When you have low traffic, that's fine. But as your traffic grows and you get more and more customers and users, they start sending not just 1 megabyte a second, but 100 megabytes a second. Now, instead of making 1 insert to ClickHouse, you're making 100 inserts to ClickHouse per second. And ClickHouse, every time it gets data, it essentially stores them into parts that it then merges to create a partition, essentially. And when you hit too many parts, it means that, ClickHouse is struggling to merge all the parts as the data is coming through. So you're sending data faster than ClickHouse is actually able to merge them. And that can lock your database. That can create a lot of issues. The answer to that is to batch data even more. There is a second answer, which is there is a flag. I forgot the name of the flag, but it's async insert or something like that, where you can send all of those. ClickHouse is going to buffer the data internally and then do the insert. The challenge with that is ClickHouse doesn't tell you if the request was successful or not. So if the insert worked or not when you are using the async insert. And what we were doing, or what we are doing, is every now and then somebody sends us a poison pill, like a bad event that we cannot insert into ClickHouse. And we do bisection to essentially identify that one poison pill and drop it and insert the rest of data. But if you're not validating that the data is successfully inserted into ClickHouse because you use the async insert, you will not be able to identify that poison pill. So that's one thing, batch your data as much as possible. Lesson 2, if in doubt, check that you have enough disk space. So we were using SSDs to power our ClickHouse cluster. And very early on, team of 3, moving fast, breaking things, we didn't really have something to tell us when we were running out of disk. And it means that we ran out of disk once. And it's a very confusing experience because you don't run out of disk on all the nodes at the same time. It's only one, like the first one that runs out of disk. Secondly, we have TTLs. So the data is also being deleted as it's being inserted, but it's just being inserted faster than it's being deleted. So you still see inserts working, but not all of them. Because you're never at zero disk. You always have that data deletion and data insertion at the same time. And yeah, this is very early on. We had only 1 TB on this node, and we ran out of disk here. And this is what the kind of network was looking like at the time. So you see this node that ran out of disk. It's just getting so much more data than every other node. And why is that? Is because the other nodes are trying, because it's a replicated table, the other nodes are trying to sync with that node that ran out of disk, but it never got to zero. So it's always getting data, deleting it. The other nodes are like, why are you behind us? Take this. And it's accepting only half of it, and they just keep sending all of that data. So it was really confusing for us to identify that it was as simple as low disk. It took us what? From 12 to 4. So yeah, when in doubt, if you're self-hosting your ClickHouse, check that you have enough disk space. Lesson 3, beware of the disks you select. So we are running on bare metal on Amazon Web Services. That is awesome. So we are using the EBS that AWS gives us, which is great. So when we run out of disk, we bump it up. We added some metrics to know when we are going to run out of disk next. And every time we get to 94% disk, we bump it up. Up until we get to here, the default general purpose disks that AWS gives you, they have a limit of 16 terabytes. And you can imagine that we got to 16 terabytes really quickly. And it wasn't really fun because you can get better disks, but then how do you migrate all of that data? How do you, it was just a pain. Especially when we had in mind, every time you run out of disk, just click here, and you have 5 TBs more. Now suddenly you click here, it doesn't work, and you start sweating. So yeah, just be aware of the disks that you use for your ClickHouse cluster. Lesson 4, mutating data is a really bad idea. I think it was highlighted earlier that ClickHouse is not really built for mutating data. Don't do it, please. It's not fun when you try to mutate data. One of the worst days of my life over the past 3 years is when I ran this query. It was so simple, and I didn't even run it in staging first. I was like, whatever. I have something that is an int. I want it to be a float. I have, 14 terabytes on 4 nodes. Just press enter. It's going to be all right. It wasn't. It locked the database. You couldn't insert anything. You couldn't read anything. CPU went crazy. Memory usage went crazy. Network in and out went crazy. Ultimately, to solve this very silly mistake, we dropped the cluster and we built a new one. And we read all of the data back from S3 back into ClickHouse after fighting with the database for, 6-8 hours on that day. So don't try to mutate data. There isn't a world where you absolutely need to mutate data. Figure out a way to do what you're trying to do without mutating data into ClickHouse. Yeah, and why is that? Because when you mutate data, ClickHouse creates a new version of the data, and then it merges it with the existing data. So it's not like I don't know how MySQL works, but I'm guessing that it actually changes the data on disk. But what ClickHouse does is, when I did this query, it created a new column, float, and then it tried to merge it with the existing one, and everything went to crap. It's resource intensive. That's what happened to me. Significant, that's a typo, significant performance impact, like it slows down everything. And we had so much data that it just blocked the database. And it potentially returns stale data to users. So sometimes a query will go through, and instead of returning a float, it will return an integer. So those are the sort of things that you need to be aware of. On that note, ClickHouse TTL mutate data. That is something that I didn't know. But what happens when you add a TTL to ClickHouse, especially the sort of TTL that is really easy to do, which is now plus 30 days, right? It means that it will delete this row 30 days from the moment it was inserted. But in one file, you will have multiple rows with different TTLs, and it will mutate that file continuously. It does it in a very efficient way, but it's still mutating that file continuously to purge all of these records that have TTLs. And that is, again, resource intensive, and it has a performance impact. It's not as bad as what I did, but you will notice that a table, I mean, I don't think you can, maybe you can. A table with the exact same data without a TTL is slightly faster than a table with the exact same data without a TTL, if I'm making any sense. Instead, delete partitions individually. So what you can do, for example, is have your partition per day. So we were offering 7-day, 30-day, 90-day TTLs, retention period for your telemetry data. So we have a nightly job that every midnight, 1 a.m., whatever, actually drops the partition, the entire partition at once. So you're deleting all the data for that day at once, rather than continuously mutating all of these files to delete all of that stale data. Lesson 6, ClickHouse default values are pretty conservative. Don't hesitate to increase them. So that's something that we learned. It wasn't too bad, but ClickHouse has a lot of default values in the config file, right? Like you can only do 100 concurrent requests. You can only do X, Y, and Z. You cannot drop a table that is more than 50 gigabyte, etc. Those are relatively conservative. Like we had partitions of hundreds of megabytes. We want to be able to delete them easily. So if you if you're stuck with something, check if it's not the default on the ClickHouse table. So the ones that we had to change that I remember are the max partition size that you can delete, the max table size that you can delete, the keep alive timeout. So we kept the connection alive with the server as we were inserting data. And I think the default is 10 seconds. We bumped that, I don't know, 5 minutes or something. And also the total concurrent queries that you can do. And checking the docs today, it's now unlimited, but it used to be 100. So you could only do 100 concurrent requests, queries, which is fine. But as your application grows, 100 concurrent queries is actually not that much. So we have alerting systems where we continuously poll your database to make sure that your latency is not more than 15 seconds over the past hour. And people had hundreds of those. So if we have a limit on only 100 concurrent requests, queries, those will fail essentially. Ship your ClickHouse logs elsewhere. Don't rely on tail. So you can SSH into your ClickHouse node and tail the logs. I think they're also right into a file there, which is awesome for really easy use cases. But every now and then you have a problem that happened an hour ago. You cannot just start searching in that giant file. We send all of them to CloudWatch, where we have better search capabilities, things like that, and we can actually debug stuff that is not live on our ClickHouse cluster. 8th lesson, ship your ClickHouse metrics somewhere. Same thing with the logs. Given that we are bare metal on EC2, this is the config to ship the box metrics. So the disk usage, the memory usage, the disk IO, the CPU usage, and the byte sends across the network. We have these dashboards, and we always kind of glance at them to know if anything is wrong. But yeah, ship them somewhere because it will help you kind of find problems before they actually impact your users. Same thing for ClickHouse metrics, ClickHouse native metrics. We ship them to Prometheus such that we can review those in real time. ClickHouse emits 818 metrics by default. And I'm not sure these are all documented. So we just dump them in Prometheus and we're like, oh my God, that is so awesome, so many metrics. But the ones that we really focus on are the time spent merging parts. That lets us know if we are not batching enough, right? Like we are getting close to too many parts. The bytes sent over the network for reads, writes, and replication. If we start sending too much data over the network, it means that there is a problem, start investigating it. Same thing for the bytes received. Slow queries, slow writes, and slow reads. So just plot them somewhere, continuously have a look, and it will help you prevent problems. Lesson 9, maintain a directory of ClickHouse queries, of useful ClickHouse queries. You will need them when crap happens at 2 a.m. And it happens, I will say with experience a little less, but early on, there were a lot of random problems that were just coming up, at the worst time. And these are not like your typical queries. I think these are the ones that I find useful when there is a problem. First of all, listing all the errors that ClickHouse is having. And you can order by whatever dimension. It's a really, really nice thing, the system.errors table. It has all the errors that ClickHouse is actually experiencing. The replication queue. So if your nodes are having issues replicating data between them, check the replication queue. It's going to tell you why that is happening. Potential issues with merges. Again, if you have too many parts or there is a problem merging your parts, this table is going to tell you why that is happening. And last one, listing the partitions. This one is interesting because, at least for us, we enable developers to put whatever timestamp they want on their logs. So you can send us now logs from the past. And when you give that capability to developers, they tend to do really silly things like sending you data from 1998 or sending you data for 2050. So listing the parts, the partitions, and making sure that you don't have anything silly like that and printing that is also pretty helpful. And the 10th lesson is if something looks odd, even just slightly, something is wrong, you should check it before it gets worse. This doesn't apply just to ClickHouse, it applies to anything that you're self-managing. Problems very rarely just pop out of nowhere. There are signs, and it's really easy to ignore those signs because the latency gone up by 15 milliseconds. It's not that bad. Something is creating that latency increase. Investigate it before it goes from 15 milliseconds to 30 seconds. So yeah, that is it. Thanks for having me. Questions? Yeah. Cloud. Yes. Here.
Yeah, there's no ClickHouse Cloud. And sounds like if there's ClickHouse Cloud, you would actually do that instead of self-hosting.
Yes, we very strongly considered it when ClickHouse Cloud came online. The main challenge was we were a very scrappy startup and we were looking for product market fit. And given that we already had a lot of the kind of muscle memory around self-hosting and the kind of effort, it's not a huge effort, but there was a little bit of effort to migrate to ClickHouse Cloud, especially because everything we were doing in that storage layer, private subnet, private VPC, all of that good stuff, we just decided, hey, let's just keep going with this self-hosting thing for as long as we can. And if at some point we can't do it anymore, we then migrate to the cloud offering.
Yeah, I guess my question is, as a founder like you, maybe it's different, but the build versus buy question, because obviously you chose the build path. But how, if you were to look at this again, how would you decide whether you should build or buy? I guess that's my question.
Yeah. So if I'm starting today, June 19th, 2024, I will probably buy rather than build, and then see how the unit economics work, and then decide if I stay in buying or in building myself.
And maybe one more question is, do you think the stack will be different if you're starting today? Or the only thing they would change is ClickHouse Cloud?
Nope. I mean, this version of the stack is the latest version, right? Like when we started, it didn't look like that. It was much worse.
Thank you. Thank you very much.
Yep.
About exporting logs and metrics from ClickHouse somewhere else. Why don't export them into ClickHouse? So use ClickHouse. You build observability backend service for other people.
Yeah.
Why don't you like spin up another instance and basically ingest things and analyze them in ClickHouse?
Yeah, yeah. So we were doing, or we are doing that for all the what's the word? Application logs and metrics and traces. But the thing is, so let me explain. Here, this is the architecture. We have a carbon copy of it just down there,
Okay.
and all the data from this and these come to the carbon copy of it, right? And for ClickHouse, just because it's such a core piece, we want to send it somewhere where if everything fails, we can still debug it, essentially. It's a much worse experience than using Baseline, but it's enabling us to have eyes on something even if everything breaks.
Okay. Thank you.
Question: do you make any backups, and do you have any experience where you need to restore your database ClickHouse from a backup?
Oh, backups. Yes. So multiple ways of backing up this data. So firstly, there is a nightly job that backs up ClickHouse using the ClickHouse backup command or whatever they give out the box. All of the data that we send to ClickHouse, we also send it to block storage for our own backups if that fails. And I know that there is a third way of backing up this data that I just don't remember. Oh, we don't do it anymore. We used to back up some of the data into the customer account directly because people want to have access to their logs, even if their provider doesn't exist anymore. And to restore data from the backups, we actually never used the nightly backups because they were always quotation marks out of date by definition. They are done nightly. So when we needed to restore some data for whatever reason, we will read it from, there are multiple things. We will read it from S3 if the issue is for more than 24 or 48 hours. But something that is not on this diagram is there is a Kinesis stream here, and Kinesis can keep data for 48 hours. So if the issue is, earlier this morning, we will just reread from Kinesis and send it to ClickHouse. So multiple ways of backing up the data, but we never had an extreme case where it's all done. We need to rely on the nightly backups.
Thanks.
Lesson number 4 about the alter table.
Yes.
Inevitably, there are cases where you do need to alter a large table. Like, do you know of any tooling? Like for MySQL, you have like Ghost and Kona.
Sorry, I didn't get that.
So for doing an alter table,
Yeah.
there are use cases where you might want to do it, but maybe you don't want to fill the whole class, like use all the resources. You might want to create a table, stream the data over more slowly, and then like rename and cut over.
Yeah. There are all of these methods that you can do, or just create a new column.
Okay.
Like if, again, the thing is, It depends really. Like you can do the create a new table, fill both at the same time up to the TTL and then switch. That is fine. We never had to do that. All the changes that we had to do after I messed up the table was just create a new column and forget about the old one.
Okay, so a new column is like an instant operation.
Yeah.
Okay.
Yeah.
Right. Thanks.
Who? Oh.
Just going back to the example when you mentioned about running out of disk space and obviously going for the realization that you can just increase it. How did you approach that problem? Did you just create another shard? And did ClickHouse, was that able to recover from that situation? Or did you have to do some other recoverability like restoring from backups?
So on this specific instance, what saved us is listing the partitions and finding that we have a ton of stale partitions that are really big and they are full of crap data that nobody's never going to look at. And we deleted them, and that brought 5 TBs back. And next to that, you can actually get better SSDs on AWS with more storage. It's just not, click on a few buttons and you get them essentially. Ace. Thank you very much.